obviously too much detail about the differential equations test. I probably just need to spend some more time with it, but it's kind of like the integrals, dilemma, like which technique do you use where? So I think I just need to sit and look at it a little bit more.
Yeah, I mean that's that's the first question for every differential equation is what technique, and um, and of course you're looking for patterns and things like that. So you kind of have to recognize those. But yeah, I mean, happy to talk about those if there's something I can offer on those. But that's what you've got to be able to do.
So I am noticing that in a lot of the problems in our homeworks, the problem was presented to us as, dy divided by dx.
Yes.
And so they're maybe not, with the exception of one of 2, 3, and 4. They're not written like that, but I think I just need to look at it a little bit longer, maybe.
Yeah. So every y prime can just be replaced with dy dx.
Right. Yeah.
So if that is needed, like for instance with exact equations or probably pretty much with exact equations, then you can just substitute that in there and use dy dx.
Right, right. The only one that is written in the form y prime, it looks to be, is number 1, which is y double prime.
Yeah, right.
So on number 5, my first intuition was to set 1 plus y squared equal to m and 1 plus x squared to y, and do that technique that we talked about last week.
Yeah, so let's talk about that for a second. I don't know if I can. Let me see if I can grab this so everybody can see what we're talking about. Give me 1 second to find the right button. It's not that button. Come on now. Oh, there it is. Okay. I gotta change this. All right, so you should be seeing my computer. You should be seeing the test, right?
Yes.
Yeah, so let's just talk about that for a second, right? Because the first thing you've got to do whenever you approach a differential equation is, kind of categorize it into one of the categories that we've been dealing with. And so, when they come to you in this setup where you've already got the dy dx split up and in two different terms, like you're talking in 5, you have what? You have how many options do you have? You have I should write off. You
Well,
have
you've got, if it's in the form where you can use an integrating factor, right? That's an option.
Yeah, the integrating factor is going to apply when you're dealing with a y prime or a dy dx together. Because the integrating factor, let me write this down. The integrating factor, if we're dealing with, sorry about that.
So, right, it's got to be in the form dy over dx plus p of x times y. So if you got a function kind of attached to y through multiplication, right, equals f of x. Yeah.
Right, right. And of course, this is the dy dx. So if it comes to you like that, then you might be you're probably going to try the integrating factor first of all, right? But if
You
you've got
can.
the two setups where you've got the mdx plus the ndy, right?
Yeah, and I'm thinking that's number 5.
You have two choices there, right? It could be homogeneous,
Uh-huh.
right? It could be homogeneous depending on the particular characteristics of M and N. And then, but if it's not homogeneous, then we see if it's exact, right? And that's what you're talking about.
Right. And so when I checked for exactness, Dr. Brewer, on that one, oh gosh, I don't have, let's see. I got that the partial derivative of m with respect to y is 2y, and the partial derivative of n with respect to x is 2x. So that doesn't hold up for exactness,
So not
right?
exact. So it's not exact, right? So you
Am I on the right path with that then?
no, you're right. I mean, that's the first
Okay.
thing. It's got to be exact for it to. I mean, it's got to meet that criteria for it to be exact.
Right, and it's not. So then does that then mean that it's homogeneous, or does it mean that it's homogeneous if it is exact?
Well, can it be? What does it mean to be homogeneous?
Well, that's the problem.
Right.
Can't remember all of it.
All of the terms have to be the same degree, right? In order for it to be homogeneous, all of the terms have to be to the same degree.
Okay, which they are.
So, well, no, because one, you know, the y squared and the x squared are both squareds, but the one terms, you know, the
Uh-huh.
the constants are, you know, degree 0, right?
Okay.
So it's not
And so you
homogeneous.
can't pull one of those little tricks where 1 equals 1 squared. You know what I mean? You know how like there are a lot of tricks that you can pull to manipulate things the way you want it to work out?
Right. No, no. Constants are always degree 0.
Okay.
Now,
So it's not homogeneous.
so not homogeneous, not exact. All right. So I've thrown you a bit of a curveball on this one. Okay. Let me write it down here. So I'll mention this because well, let me write it down. I'm mentioning it here so that I can just, if other people have questions when they face this on the test, I can just say, hey, watch the recorded session from tonight, right? So remember, the other thing that we can always try to do is see if they are separable, right?
Right, yep.
You guys are seeing that, right?
Yes.
And so this one comes to us, you know, if I just move, if I move this guy over underneath and this guy underneath, then all of a sudden it looks like this. 1 plus y squared over, we'll throw the negative, 1 plus x squared equals dy dx. Okay, so there it is. And remember, in order to be separable, we needed dy dx to equal some function of x times, or some function of x times some function of y. We needed to be able to write the right-hand side as a product of, and
Yeah, you've got to be able to get the x's on one side with the dx's and the dx and the y's on the other side with the dy.
yeah. And this one looks like it's separable.
Okay.
Right? I'll just give you one other hint as you work your way through this. Remember, check your integration tables.
Oh, okay.
Just because it's some integrals that we've seen. You've seen them since Calc 1, but they're the kind of integrals that, you know, are easily forgotten, and so you forget that, oh, I can do that. So anyway, I'll put that hint there. I think you should be okay on that one. But so there we went. We went through an analysis of several different kinds of problems. So hopefully that was helpful.
Okay. Yeah. Thank you.
Can I ask a question? Oh, can I ask a quick question?
Absolutely. Is Rose still here, by the way? Any Rose? Did Rose leave us? Okay. Just checking. Yeah. So, question. What was your question?
Yeah, I have two just quick questions. I emailed you or sent you a message about one of them. I just wasn't sure what to do with this. So if I just like tell you it, could you write it out and then?
Yeah, let's try it.
Okay, so the integral of v over u times du over 4v. And then equals the integral of dx over x. I know like the v's cancel and then you can bring a 1/4 out.
Yep.
I just was wondering where you kind of went with the 1/4. Like I can tell it'd be like 1/4 the natural log of u equals, well, you can do it out.
Yeah, so now the 1/4 can either stay there or it can move over here as a 4, right? And
Yeah.
and the reason we might do that is because we kind of prefer to muddy up the waters on the x variable, on the independent variable x, rather than on the
Okay.
things that we do on the u. So I would move that over as a 4, so that's gone. And then, like you say, that's ln of u equals 4 ln of x plus c, right?
Mm-hmm.
And
actually, just real quick, would you have to? Oh yeah, there you got the parentheses. Never mind.
Yeah.
Bring it onto the c.
Yeah, so it's going to be ln of x to the 4th plus 4c, right? And then we'll just call that 4c a new constant, say c sub 1.
Okay.
And really, you know, I'm sorry, I need to be a little more, you know, let 4c equals c sub 1. So getting a little fast and loose here, right?
Yeah.
But now, have we answered your question, or do we need to keep going?
I want to see what it looks like at the very end.
Okay.
I don't remember what u is, but you can just keep it as u.
Okay, so all you're going to do is exponentiate both sides, right? Take e raised to the left side must equal e raised to the right side. That gets rid of your natural logs. And so you'll remember this trick, right? E to the ln of x to the 4th plus c sub 1 equals e to the ln of x to the 4th times e to the c sub 1. And then we do it again. Let e to the c sub 1 equal a new constant. And so we end up with u equals x to the 4th c sub 2, or better yet, c sub 2 x to the 4th.
Okay. Okay, I think I was trying to do it with like a 4th root or something.
Yeah, I mean, if you leave the 1/4, I mean, it all works out, but it's just cleaner this way. If you leave the 1/4 on the u, then you end up with 1/4 ln of u, which becomes ln of u to the 1/4, right?
Yeah.
Which then you exponentiate, right? And you have this other side that you're exponentiating this stuff, right?
Mm-hmm.
And you end up with u to the 1/4 equals e to the this stuff, and then raise everything to the 4th power.
Okay.
So it works, but I think it's easier if you dump the 4 over with the x's.
All right. Thank you. And then I have like one other quick question for you.
Okay.
It was one of the examples on the video, and I didn't like follow all the steps. I don't know how far back to go. Maybe if you want to, it's y prime plus 3 over x times y equals 2x to the 4th. And so this is like one of the factor ones, integrating factor. And in the video, I didn't get like sometimes there was an E and then it went away and then it came back and I just didn't follow it all the way. So I know the integrating factor is like integral of E to the 3 over x dx, and then that ends up being E to the 3 ln x. And which would just be x cubed, right? Or
Yep, that's right.
okay. So like when you bring this down, I mean, are you technically just multiplying both sides by x cubed? Okay, you are, right? And then you integrate after that?
Yeah, so what happens is you have this.
'Cause-
Go ahead.
yeah. And then that turns to just, well, in the example on the video, you kept like 3 ln of x, and that's what you multiplied to both sides. And then there was not an E, and then there was an E on the next line. But you can just multiply both sides by x cubed, right?
Yes, that's what you're supposed to do. You're supposed to multiply both sides by x cubed.
Okay.
Now,
And then you integrate, right?
yeah, I mean, yeah, because this side right here boils down to the derivative of what? X cubed y.
So it would be like y, yeah, y of x times x cubed. Okay. And then you just integrate
Right.
the other side.
Yeah.
Okay.
I should add a caveat to all my videos that they do not come guaranteed.
You do a very good job at making it. I think you explained it very well. I just, I couldn't follow the.
So if you finish that guy out, you're going to have x cubed times y equals x 2x to the 8th divided by 8. You have to integrate both sides, right?
Yes, that's right.
Yeah, there we go. Okay.
And this is dy dx, by the way.
Yeah.
Yeah, and then you divide everything by x cubed because you want to get y by itself if you can.
Would you have to divide like the c by? You'd divide c by x cubed also, right? Like everything else.
Absolutely, absolutely,
Okay.
yes.
Yeah. All right. Thank you. I think that was all I had questions on.
Okay, good questions.
Thank you.
No, Rose, you there? She was here, but I don't see her.
I'm here. I'm just listening.
Oh, there you are, Rose. Yes, good. All right. Listening is fine.
I don't really have any. Yeah, I don't really have any questions right now because I've been working all day on it, and I think I'm at a point where my brain is fried. But I thought I would at least listen and take some notes in case something stood out to me.
You know, it's such a tough way to learn. You know, from videos. You know, so I can appreciate that. Sometimes you just, need to have a little back and forth. Of course, you guys all know that. But yeah, so I have I have some empathy for you guys learning this way, and so I hope that we can every once in a while pop on and help you, give you some live, in color mistakes rather than just recorded mistakes.
Oh, I did have a question actually. Are you going to do lecture videos for 3.2 and 3.3, or is it just the textbook?
No, are you not seeing them?
They're not under. I don't know. Maybe just didn't publish the module. Because I can find the PDF of the assignments and where you submit them, but when I go into modules.
So you go to modules.
It wasn't in modules.
So it might just not be published yet.
Oh man, that's not.
But you can go to pages, I think is how I went through pages, I think, and that's how I found the videos for 3.2. And I can't remember 3.1.
They're on pages. Yeah, they're on pages. Just go to pages and everything is there.
Okay, thank you.
I am sorry. I forgot that I'm putting them there on modules now. I forgot that I had to add them under modules too.
Oh yeah, I found them just fine. So I just.
Yeah,
Thank
no,
you.
that's a good reminder, but they're there now. Yeah.
Okay.
Yeah, so they are in the pages. Anyway, I hope nobody else is getting lost from that poor organization.
Oh yeah, they're there. Okay, cool.
So thank you for letting me know.
Yeah.
All right. What else can we talk about?
I did have a this is Rose. I just was wondering about how many more assignments we're going to do till the end of the semester.
Good question. So we've got what, 2.5 weeks this week and then 2 more. Am I right? So the plan is to go 3-4, 3-5, 3-6. And then well, we're kind of adjusting some things here. And then hopefully at least 3, maybe the first 3 or 4 sections in chapter 4. We might mix in a 3-7 in there as well. So to answer your question, between 6 and 8 more sections. Did you hear that all right?
Yes,
Okay.
I did. Thank you.
If I could, I'd keep you here all summer and we'd do some really fun stuff. But we got to pick and choose. Anything else you guys want to talk about?
Oh, actually, I did remember one thing. Now I don't have it in front of me, but on 2.1, when you're doing the systems, I think it's like if they're inconsistent or something, some of the solutions have like an expression with T in them.
Yes.
Is that something we're going to be needing to know how to do?
Yes.
Okay.
Should be some examples there in the videos if you haven't seen those.
Oh, really?
But I mean, yeah. So if you want to check those out, that you can see it happening there. If not, we can even look at it.
I can try. I'll look at it, and then if I have questions, I'll let you know.
Okay. Yeah, because really, to be honest, finding a solution, you working with a system of equations that has a solution is fairly boring. That's we can do that. What linear algebra does is we start digging into the systems that have an infinite number of solutions or 0 solutions and seeing what we can learn from those. So that's going to be kind of important that you understand how to come up with those parametric solutions when it's a infinite case.
Right.
And do you guys all have TI calculators?
Yep.
So of course TIs can handle those fairly easily. And in the 3.3 stuff that I've published today, I talk about some technology stuff with calculators and with GeoGebra.
So I have a question, if nobody else does.
No, you are next. Go for it.
Okay, so going back to 2.1, I watched the videos and I thought I understood, but I cannot get the answers that are in the back of the book. So I'm making a mistake somewhere. So I don't know if you can just walk me through one of those beginning problems, like number 5 or something.
Sure, let's take a look. All right, so we've got number 5. So you want number 5? You're good with that one?
Number 5 would be great because I'm way off track. I don't know what I'm doing wrong.
So were you able to actually solve the equation and then or not?
Yes, but it's wrong. So I guess uh, because in my head I'm separating these first, right? So like on the left I'd have 1 over 3x times 5 minus x dx. And then I just have dt on the right.
Yep. Let's do a 3dt since we
Oh,
now that won't matter. That won't matter. I'm not saying that that's the problem.
it could be though, because I'm getting, I don't know.
Let's
And
do
I
it your
think
way.
no, show me a better way because my ways got me frustrated.
Well, I want to do it. Let's do it your way so we can see, if what's happened. Because what's going to happen is actually when we go to integrate this, right? We're going to end up pulling that 1/3 out and trying to integrate dx. I don't want to do that. Integrate dx over x 5 minus x, right? So the 1/3 is just going to hang out while we do our work.
Well, and maybe that's my problem, even just right there, because I was trying to do it where you break it into the two different fractions. I was leaving that 3 in there. And I was doing like a over 3x plus b over 5 minus x.
Let's compare those two. So if you do it without the 1/3, it's going to be a over x plus b over 5 minus x. No problem there. Multiply everything by. You guys scream at me if I'm jumping too many steps here. To end up with a 1 equals a times 5 minus x plus b times x. And then we'll do a couple little substitutions. Let's let
X equal 5.
x equal 5. So that wipes out the first term, and that tells us b equals 1/5 if I've done that
Yep.
correctly.
Which
And
is, I think, what I got anyway, but keep going.
0, right? So
Yeah.
that gives us a equals 1/5. So we end up with this, right? The thing we are trying to integrate, this guy right here, is 1/5 over x plus 1/5 over 5 minus x. But both of those 1/5s we can do a couple things with them. Maybe the easiest is just to factor them out of both of those. And then now that joins the 1/3.
Okay.
And so we're integrating 1 over x plus 1 over 5 minus x.
Okay.
Okay, and so the 1/15th will have what? ln of x.
Yeah.
Now what's the integral of 1 over 5 minus x?
Isn't it negative natural log of 5 minus x?
Yep. And so that is the left side in yellow, right? And then the right side in green, not that green, this green. The right side in green is just t plus c.
Okay.
Now we were gonna, okay, so the question was, because I'm actually a little curious myself. Let's do a little side trip here. The question is, what if I leave the 3x in there? Does it make a difference? So it'd be a over 3x plus, it might make a difference. We'll see. B over 5 minus x. I think, yeah. Okay, we'll see. We'll see. I'm feeling like it's going to make a difference because I feel like this should break down into something over 3, so something thirds plus something over x plus something over 5. We'll come back to that. I don't know.
Oh, I see, maybe.
You see what I'm saying? But let's just see. So 1 equals a times 5 minus x plus b times 3x. And so if we let x equal 5, then that wipes out that first term, and that gives us b equal, hey, look at that, 1/15, right? I think we're okay.
Mm-hmm.
And then I bet you that if you let x equal 0, no, there's your problem, right?
No, that's the problem right there.
B
Yep.
equals 1/5, and so that's not going to work.
Right.
I got that right. A equals 1/5. Yeah, so would it be better to have it as something over 3 plus some, I don't know that this will work, something over x plus something over 5 minus x. Sorry, we're going to extend over here. That gives us 1 equals a times 3x 5 minus x, not 3. Plus b, x is gone, so times a 3, 5 minus x, plus c, 3x. Okay, let's just see. So we can let x equal 0. That wipes out the a term and the b term and gives us b equals 1/15. If we let x equal 5, that wipes out the a term and the b term and gives us c equals 1/15. That's good. Those are both what we need. And then we don't get to do any of these clever things anymore, but we get to just let x equal anything we want and use the two values that we know there and there. Kind of ugly, but let's just see what it says. So let's let x equal 1. That's simple. That's our simplest choice. So we have a is unknown, and it becomes 1 times 5 minus 1 is 4. I don't know. I'm not having a lot of confidence in this. B is 1/15, so that becomes 3/15 or 1/5 or 4/15. Did I do that right? 3/15. Sorry. Let me be a little more careful there. So B is 1/15, so it'll be 3/15 times 4. That's 12/15. Plus C. C is 1/15. 3/15. 3/15. That's interesting. Yeah, look at that. A equals 0, right? Hey, we like that. Because 12/15 and 3/15 become 1 and kill the 1 on the other side. And so you have 0 equals 4a, right? Okay. So we're okay either way.
But that way is a lot more complicated and I think more prone for me to make errors.
Oh, easily. It's just easier to pull that 1/3 out here and go from there. Okay,
Right.
so
I need to watch for that. Okay.
Do you feel like you can go on from there, or?
I feel pretty comfortable, but as long as we're here, you can go ahead and show me all the way through.
Okay.
That would be awesome.
Can I ask a quick question about that problem, Dr. Brewer?
Sure.
Would you at this point multiply both sides by 15 to get rid of that 1/15? Or would you not do that?
Yes, because we know what's going to happen. We're going to have to eventually exponentiate. The less stuff that is on the left, the better. So I like that idea. Let's do it. ln of x minus ln of 5 minus x equals 15t plus
And you
15c, but let's give it a new name, right?
Mm-hmm.
I am happy to stop and explain further any of these things. So don't feel like I'm just anyway. Just interrupt me if you need something explained. I'm just going until I hit the speed bumps that you give me. So there we go.
So on the left-hand side, sometimes I see the second term on that ln when you combine those natural logs. Sometimes I see that 5 minus x as the numerator. When is that second term the numerator and when is it the denominator?
Well, the rule is this, right? ln of something minus ln of something else is always ln of the first minus the second. So that's always the rule, and unless so maybe there's some
Wait a minute.
simplifications.
What if it were negative ln of A minus ln of B? How would you treat that?
Yeah, I would probably factor the negative out. Well, I think that is what I would do, right?
Okay.
And then that becomes, sorry, don't skip around on me. What are you doing there? That just becomes negative ln of AB, right? Because the property is if you're adding logs, it becomes the product.
Okay, how about this one? Negative ln of A plus ln of B.
Okay, there's your difference, because you would write it like this, right?
That's it. That's what I'm seeing. It's when the negative is in the first term. Okay.
Yeah. So the negative is, the negative is always going to be in the denominator. The positive one will be always in the numerator. Oddly enough, you could even, I'll just squeeze this in there so you can verify this on your own. This could be just, like I said, the negatives would be in the numerator. See if you can figure that one out. That's also, so that would also work at that one.
That makes sense.
Right? Because if you look at this guy, if you take that negative as a -1, move it upstairs as an exponent on the AB, you have ln of AB to the -1, and that is the same as this. So, so maybe, the rules are negatives go in the denominator, positives go in the numerator. All right. Okay, so we are about to exponentiate, right? Bam,
Yep.
and bam. So that cleans the left-hand side up. Remember, x is, in this case, is actually the name of our function, right? T is the independent variable. So I'm going to do this. You guys scream at me if you don't like it. But that's the right-hand side, right?
Mm-hmm.
And we can solve this for x, right? So this becomes a Newtonian algebra. Let's try to not mess this up.
You're still doing that.
I took a break. How was the hike?
So I'll get all the x terms together.
Yeah.
And so you don't need that constant on that second part
I called it a new one, right?
on the x part.
Oh, yes. No, good catch. Thank you. Don't lose that. Right there. Thank you.
Yeah.
Right? Is that better?
Yes.
So C sub 2 follows us over there. And that gets our 2. So we're to this equaling this side. That's where we're at. We move the x's
Yep.
together, and
Yep.
we now have C sub 3 e to the 15t, and factor out an x, right?
Yep.
And divide. So you end up with C sub 3 e to the 15t over 1 plus C sub 2 e to the 15t. And
Yep.
we have to leave it there. So there's our solution.
So why do they have x of t is equal to 40 over 8? Am I looking at maybe I'm looking at the wrong place for the answers.
No. We're not done yet, right?
So I guess okay.
Right. We
Now
have
we're
the
not
initial
done because
condition.
x of 0
Was
is
Was
8.
there an initial value given?
Yes.
Yes. So is that where? Okay.
But
Yeah.
I'm having just a little bit of, I don't know, I'm a little bit
Solve for
concerned here.
Do we have to solve for C?
Yeah. Isn't that the whole point of having the initial?
Okay, so we better, I think we've got way too out of control here, and I blame that on the stay-at-home conditions, right?
I was gonna say, you can blame it on me. I'll take it.
So here's our problem. Yes, normally we would need to find our constants, right? But here's the
Yep.
problem. If you have two constants, you need 2 points to find those. All right?
Oh.
We only have one data point. So what happened? Well, we got to introducing some constants that were actually doubling up some things. So let's see if we can retrace our steps here. We don't want to just totally lose all our constants. So let's start with our first one. Our first one was, I think we're good with this, that we had 15c equals that was our first substitution, right? I'm going to see if I can do it this way.
Oh, so we're having to leave those in instead of getting a new constant? Is that what you're doing?
We want to keep everything in terms of C.
Okay. So no. Okay, that makes sense.
Can
Sorry.
we back? Sorry to interrupt. Can we back up a little bit? And what did we get A to be, and what did we get B to be?
Oh, we got them to. Okay, so we did a lot of work here. By the way, we decided that. Let me just make this clear. We decided that this didn't work. That particular method.
It looks like I had to step outside and talk to my neighbor. We had an emergency here in South Jordan. There was a murder-suicide a couple of hours ago. So, so I ran outside at the very beginning of this problem, but I got A to be 1/5 and B.
Yes.
I got A to be negative 1/5 and B to be positive 1/5.
Let me go back. Here we are right here in our original work there.
Yeah, I got one of those to be a negative.
On
the right-hand side, I got it all. I'm trying to follow the work. Okay, so where you've got those integrals highlighted with yellow and green, 3 line, yep. I got, I worked up to a point where I got the integral of -1 over 5x plus 1 divided by 5 times x minus 5 dx equals -3 dt.
Okay. So I think we're just missing. I mean, you've got an extra negative in there somewhere. So we had this 1/3 that we pulled out from here, right? From here. So that we don't have to worry about that, so that we're just worrying about that. So that 1/3 is going to stick around. Now, so what we've got to do is we've got to take this and decompose it using partial fractions. And
Right.
so there it is, right there. The two partial fractions are going to be those two. Okay, so that's your setup right there. And notice everything is positive. And then we multiply by this to make it this. Okay, is that, are you up to speed on that so far?
Okay, I'm following.
Okay, and then once you're there, then you let x equal 5. That wipes out this term. Right? That wipes out that term, gives you 5b equals 1, so b equals positive 1/5. Then we let x equal 0, which wipes out that term, gives us 5a, and so a equals 1/5. So they should both be positive 1/5 right there.
Yep.
And then, so you got the 1/5 out in front of everything. So you factor that 1/5 out to just clean it up. You don't like fractions on top of fractions. 1/5 comes out, hits the 1/3, becomes a 1/15. Now, this right here is tricky because when you integrate this, that's ln of x, no problem. But when you integrate this thing, you're going to end up, you could do it by substitution. What you end up with is a negative ln of 5 minus x.
But just to get my thinking straight, if that would have been 5 plus x, you wouldn't have had that negative, right?
That's right. It would have been a positive right here.
Okay.
Is that okay? I'm going to put a big question mark through this because, you know, it's always good to, what did I do? Maybe I just deleted it. No, did I do? Come on back. There we go. Because this was the work that wasn't working out. I think we're okay, but we'll leave that there. I want to pick back up at the start. So I want to pick up back up right there. Let's just verify one thing to convince ourselves that the integral of integral of 1 over 5 minus x is what we say it is, right? And so we do use substitution.
Yep.
And so that's what we get. And so when we substitute, we get a 1 over u. And then for dx, you're going to put in a negative du. That's a weird way to write it. But anyway, there you go. There's your negative du over u, which is negative ln of u, which is just like we said. So yes, we're good.
Okay.
All right. Are you up to speed with us, Carolyn?
I believe I am.
Okay, we're going to have to do this. We need more digital paper. Okay, so our problem right there, we're just missing our parentheses. Okay, so then what we decided was we don't like that 1/15 on the left. We're going to move it to the right. Now, we're going to keep all of our constants. This way we don't end up with what look like multiple constants. We just have one. So we have 15C right there. Okay. And so now we proceed, right? Now we go E to both sides. And that is going to give us, oh, sorry, we got to do this first. We have ln of x over 5 minus x equals 15t plus 15c. And e raised to both sides now gives us x over 5 minus x equals e to the 15th t, e to the 15t, e to the 15c. Okay, we're going to keep that there for now. Instead of, we're not going to do this because we don't want to.
And we're even going to keep that E there?
We're going to keep the e there.
Okay.
I mean, I think, where did let me go back here. Maybe I'm making a mountain out of a mole here. Let me just double check. C sub 2, that shouldn't matter. And then we brought it through. Oh, I know the problem. We were okay. It was this C sub 3 that killed us. We needed to leave that where it was in terms of C sub 2. So let's go.
So that they're the same constant, where they're both C sub 2, they would be the same? Is that why?
Yes, you don't, because it's the C sub 3 that we identified here was equal to 5 C sub 2. And so by introducing a C sub 3, it looks like we have two unknown variables, unknown constants, where in fact C sub 3. So we could actually probably just call this what it was. Okay.
Just C sub 2.
But we've gone around so many corners. Let me not do that.
Thank you, though, and it feels so good to have these questions answered. Thank you so much.
Okay, this one we are safe to call a new constant because it does not depend on anything else.
Okay.
And so that, Carolyn, you okay with us?
Yeah, can you humor me and, okay, go ahead.
Yeah. I mean, we're not now we're gonna work it on out. I mean, so far up to this point, I think that's pretty standard stuff. That little trick right there of just calling that C sub 1 is no big deal. Okay.
I'm not sure I would know how to do it the other way.
Well, I'll show you, right? Yeah. I mean, the other way worked just fine. You just keep all of those terms in there. You'd keep the e raised to the 15c in there, and it's just going to float around and make everything complicated. But we need to solve for x, so we need to go ahead and distribute this through here. So we get a 5 minus c sub 1 e to the 15t x. This is where we made our mistake before. We just grouped these together and called them a C sub, a new constant, but we want to leave it there because we don't want a new constant. And so you have x plus C sub 1 e to the 15t x equals 5 C sub 1 e to the 15t. Let's use this unused space up there. Factoring out the x and moving to the other side. So we have 5 C sub 1 e to the 15t over 1 plus C sub 1 e to the 15t. See, just one constant because we kept it through.
Okay.
And chime in if you've got questions. This was our initial condition. So we should now be able to use that to find out what C sub 1 is. We just plug in 0 for all of the t's. So it becomes e to the 0, 1 plus C sub 1 e to the 0. And that should equal 8. So we end up with 5 c sub 1 over 1 plus c sub 1, right?
Yep.
Or 8 plus 8c sub 1 equals 5c sub 1. And so if we do this without a safety net, we should get what? Negative 8/3 equals c sub 1. 5c minus 8c is negative 3c. So there's our constant.
So 8 minus 5 would be 3. Okay. I was a little bit slower on that. Okay, I'm catching. Ah, I see.
And that could be cleaned up a little bit. Yeah, that's okay. I think that's okay.
Sweet.
Yeah, so we took our own sweet time solving that problem, but I think it's kind of good to see some of the ins and the outs there.
Thank you.
Not a problem. Carolyn, any questions on that? Did we answered a few, then we went forward?
So I did get that C was 8/3, not negative 8/3, and I'm just sure I dropped a negative somewhere.
Well,
But
could
yeah.
be, but let's see. I don't know. Double check through it. I'm not seeing something immediately that stands out.
No, yeah, it looked like you went through it pretty methodically. So I'm sure the mistake is on my part.
Those wonderful negative signs.
Well, will you be around by email tomorrow? Because I need to really kind of get into this test with more vigor tomorrow before I don't want, the due date's not till the 11th, but I can't let it get that far away from me because it's just so loosely in my brain.
Yeah, no, I'll be around. I'll be around.
Okay.
Maybe not first thing in the morning, but should be after 10.
Okay. I've got a meeting in the morning anyway at school, so.
Okay. All right. Well, if you guys don't have anything else, contact me. Feel free to send me stuff. I know sometimes I don't get to. I don't get replied to you before you solve it yourself. But anyway, feel free to keep trying.
Thanks so much, Dr. Brewer.
Okay.
Thank you so much.
Thanks for coming. Have a good night.
You too. See ya.
Bye.